Okay, so looking at homework 6, we're starting out on number 7. So we've got negative 4x to the 4th, x squared plus 9x plus 7x to the 6th. Little keyboard thing? Yeah. That's just my computer trying to make life hard on me. So, you got to distribute the negative 4x to the 4th. Pretend that looks like a 4. Negative 4, this is a 1x squared, so negative 4 times 1 is negative 4. X to the 4th times x squared is x to the 6th.
Oh, whoa, that is a 4. Sorry. I was thinking 14, I don't know why.
Because I made it look like a 14, probably.
That could be.
Then negative 4x to the 4th times 9x. Negative 4 times 9. Negative 36. X to the 4th times x. Again, that's x to the 1. X to the 5th. And then we have the 7x to the 6th here. So, looking at this, we have negative 4x to the 6th and positive 7x to the 6th. Those have exactly the same name, so we can combine them. Negative 4 and positive 7 make positive 3x to the 6th. And we still have the negative 36x to the 5th. Because this is x to the 6th and x to the 6th, this is x to the 5th, so it's slightly different. And that is a common struggle for a lot of students. Is they're all x's, why aren't they the same? But they not only have to have the same variable, they have to have exactly the same power.
Okay, go to 8.
So number 8. Number 8 just is written kind of funny. Number 8 makes more sense if you rewrite it like this. And now it looks just like any of the other ones we've multiplied. So now we've got the negative 9x to the 3rd times 7x squared, so that's negative 63 x to the 5th. And then negative 9x to the 3rd times 8. Well, negative 9 times negative 8 is a positive 72. And then it's just x to the 3rd because there's no other x to combine it with. I know. But it's a universal phenomenon in math. Is when somebody else is doing it or somebody else is helping you do it, it looks really simple. The tough part of doing math is figuring out what to do next. Yeah. See, once you know what to do next, the calculation is easy. The hard part is looking at it and figuring out what's my next move, what's my next step. And when somebody else is doing it for you or helping you with it, they're giving you hints, or I'm giving you hints as to what comes next, and I'm leading you to it. Number 9.
Trust me, I'm next.
We're in the real world now, Cody, not your world. Okay, this one we're looking at an algebraic expression for the area. Well, area is length times width. Now we can call either one of those the length or the width. I prefer I'm going to put the x squared first as the length, just because it's the simpler expression, times 5x to the 5th minus 6. So I'm going to call this 1x squared. 1x squared times 5x to the 5th. 1 times 5. 5x squared times x to the 5th. X to the 7. 1x squared times negative 6. Negative 6x. There we go. So 1 times negative 6 is negative 6. X squared times nothing is x squared. I'm guessing number 10 might be next?
Yes, it is.
Okay.
You're good.
So,
Did you get mine?
No, it's mine.
Kidding.
Oh,
Yeah.
got it.
So volume is length times width times height. So I'm just going to multiply these two dimensions together. Again, I'm going to put them in order from the smallest or simplest to the most complex, just because it makes life a little bit easier on us. So I'm going to start out, I'm going to multiply the first two. X squared times 6x to the third. So 1x squared times 6x to the third is 6x to the fifth. Then we still have to multiply the 5x to the fourth minus x to the third. Yeah, but you can't combine those. That's x to the fourth and x to the third, so you can't combine those. So now we have the 6x to the fifth times 5x to the fourth makes 30x to the ninth. Good. 6x to the fifth times negative 1x to the third. Careful. Negative 6. 6 times negative 1 is negative 6. X to the eighth. That's the second time you've done that. You got the negative 1 times the number and you're adding instead of multiplying. And it is easy to fall into that because you're adding the powers, but you're multiplying the numbers. Yep. Okay. Number 11 is asking us to write an expression for the perimeter of this when we're given 4x to the third plus 9x squared is the length, 7x squared minus 3x is the width. And remember, perimeter, 2 times the length plus 2 times the width. So we're going to plug in for L, 4x to the third plus 9x squared. Just replaced all of that. And for W, we're going to replace it with 7x squared minus 3x. Then we need to simplify this expression. So we're going to multiply by 2 here. 2 times 4x to the third is 8x to the third. Two times 9x squared is a positive 18x squared.
And it's positive because you just have to have something in between.
You have to have something to link them together. So it's positive, so you put a plus there. Come over to this other set of parentheses. You have the 2 here. 2 times 7x squared is 14x squared. So again, it's positive, so plus 14x squared. And 2 times negative 3x is negative 6x. Are we done?
I got it to there. It's right
Okay.
here that I messed up.
Once you get to this point, you have to ask yourself if there's anything that can be combined. And to combine, they have to have exactly the same name. They're all x's, but they're different powers. But there are 2 that have the same power. The x squared is good. So the 8x to the third is going to stay the same. There's nothing that combine with that. But 18 and 14 make a positive 32x squared. And negative 6x. What's that?
What's 12 here?
12. 12 gives us a headache, doesn't it? Is 900 divisible by 2?
Yes.
Yes, it is. How about, here, we'll keep going with it. 3? Yeah, 9 plus 0 is 9. So it's divisible by 3. How about 5? Yeah, it ends with a 0 or 5. Here, just to make myself feel better.
Oh,
Yay!
good job.
I feel validated now. The computer told me I did a good job. So I don't care what the rest of you say anymore.
Well, then we can just leave.
So here, 0, prime, composite, or neither? Well, there are two numbers that are neither. That's 0 and 1.
Yeah.
So this is neither. 25, prime, composite, or neither. Composite. Why is it composite? Yeah, it can be made up of, it can be multiply smaller numbers to get it. 5 times 5 makes 25. How about 1?
Neither.
What's that, Cody?
You know the first thing you say when
19 is prime. There's nothing that divides into 19 other than 1 in itself. 30. Composite. 8. 35. And 57. Divisible by 19. And 3, by the way. 5 plus 7 is 12. So it's divisible by 3. Just remember those rules. If you add up the digits and you can divide that sum by 3, the whole number can be divided by 3. When I'm looking at divisibility for a number, I usually look for 10 first, because if it ends in 0, of course, you can divide it by 10. And then 5, because that's just as easy if it ends in 5 or 0. Then from there, I usually look for 2's, because if it's even, you can divide by 2. And then I'll look for 3's, because then you have to add up the digits. And if I can divide out the 10's, 5's, or 2's first, sometimes I get down to something small enough, I just know whether it's divisible by 3, so I don't have to add the digits. But if I get to that point and I still don't know for sure, I can still add the digits and see if that sum is divisible by 3. And then if it's not any of those, then you start looking for the odd ones like 7 or 11 or 13.
Yeah, try to get rid of it.
Yeah. On a test, I won't.
Go ahead, say it.
For the right donation, none of those will ever appear on the test. How's that sound? Notice I paused the recording so it can't be
I
used
see that,
against
that
me
was
later.
funny. I was going to say it at 12, 11, into the, yeah, dang.
So, anyway. You guys need to keep going to number 14 actually gets into what I wanted to talk about a little bit today.
And then after that, can we do the one I was talking about?
The factoring with the powers or the calculator?
No, the one that has a perimeter of 84.
Oh yeah, we'll get to that one. We will get there.
Okay.
So if you factor 28, we did the factor trees.
Yeah.
You might have like 4 times 7 or 7 times 4, however you want to break it down. Are either of those prime? 7 is prime. 4 can be split up into 2 times 2. So 28 factors to be 2 times 2 times 7. So if I were filling this out, that's where I'd put a 2 there. But then here, what's this asking us to do here? Well, we didn't really talk about that yet. There's a shortcut for writing our factors. We can put it in exponential form. Instead of writing 2 times 2, I can write 2 squared times 7, like that. That's all this is asking us to do, is put it in that form. Instead of just multiplying by 2 2's, make it squared. So you might end up with, let's do something like prime factor 120. What's a number that divides into 120? 10, and 120 divided by 10 would leave us with 12. 10 can be split up into 2 and 5. Those are both prime. 12 can be split up into 2 and 6 works. The 2 is prime. 6 is 2 times 3. So what we have here is 120 is 2 times 2 times 2 times 3 times 5. I can write this instead of 2 times 2 times 2. If I wanted to, I could write it as 2 to the third times 3 times 5. That's all when they're saying about exponential way of writing it, or writing it in power form or whatever. That's all they're asking you to do, is to do that. Condense them like that and make it a power instead of writing the same factor over and over again. Those two things mean exactly the same thing, by the way. On a test, I'll accept your answer either way. Oh, that one you can have for free. So now you want to define the one with the
84 is the perimeter. Maybe it was in the test.
Oh, I'm sure it's here. Let me pause this. Our fractions, we talked about starting to rename our fractions. Fractions, we said, have a count and a name. The top number is a count. This says we have 3 of something. The bottom number is a name. We have force. Is it possible to have 0 force? Is that a legitimate fraction? Actually, it is. I have 0 money some days. That's possible, right?
With your life, that is.
Yeah. It takes 4 items to make a whole object, and we have none of those items. So that is very possible. So that's okay. That's actually just equal to 0. That just means you have nothing. You're 0. How about to have 4 zeros? Is that possible? That's not possible. Because this is saying it takes 0 pieces to make a whole object, but you have 4 of those. Well, how can you have 4 of them if it takes none of them to make an object? It just doesn't work. You cannot divide by 0. If you try to divide by 0, really bad things happen. What? This is 0. This is not 0. This, if you try to type that in your calculator, 4 divided by 0, it'll give you an error. Dividing by 0 is one of those things that a lot of people take it for granted, but there are serious consequences. In the late 90s, one of the Navy's nuclear-powered aircraft carriers in the middle of the Pacific, their navigational system, what they did, pretend that looks like the boat. Here.
Sorry. It just looked like a little smile.
There's their boat. They're in the middle of the Pacific. Their navigational system, what they did was they had just gotten into the satellite locationing and stuff like that. Navigation was just getting very, very dependable. So they're doing all their navigation satellite. They would put in the coordinate of where they wanted to go, where they needed to get to, and the computer would contact the satellite, get their exact location. It would calculate the shortest navigational path there. Now, we've always been taught that the shortest distance between 2 points is a straight line, right? Well, on the globe, that's not true, because the globe is not perfectly round. It's actually oblong. The world is actually slightly wider at the equator. It's wider this way than it is tall. Because of that, if that ship is going from here to here, the shortest navigational path is actually a slight arc. Because you're actually going like over the top of the Earth instead of around the side of the Earth. So then that computer would calculate that navigational arc and program it into the boat system. Well, in this particular instance, when they put in this coordinate they wanted to go to, it just so happened to be that it lined up with one of the coordinates that the ship was already at. So that when the computer did its calculation, it ended up subtracting those 2 numbers and got a 0. And then later tried to do a division to calculate the rate of movement in that direction. And nobody had programmed in a safety. I mean, the odds of it actually hitting those 2 coordinates being exactly the same was phenomenal. They'd been using this navigational system for years at that point and had never had an issue. Just on this particular instance, it happened to hit. And when a computer tries to divide by 0, if there's not a safety built into it, anybody know what happens to the computer? It locks up. It crashes. They had to shut down the computer system and reboot. And if you're not familiar with large computerized structures like that, submarines, aircraft carriers, things like that, you are looking at several hours to reboot the computer because you have to shut down all of the systems and reboot. I mean, you're probably looking at 5 to 6 hours that ship sat dead in the water trying to reboot its system because somebody didn't think to make sure it never tried to divide by 0.
Now it has a fail.
Now there's a safety in there to keep it from doing that. Yeah.
And now you just traumatized us because your windows started to leak our whole life telling us that the earth is not round. So therefore, I believe we should all deserve 100 on the next test.
I'm all for that.
I didn't say the earth was flat. It's just not perfectly round.
It's always in a ball. I never knew that.
Oh, yeah?
It wasn't a perfect one.
Well, it's physics. The earth is 15,000 miles around. And it spins around. It spins around in 24 hours. So if you do the math on that, that is about 625 miles per hour. That the surface of the Earth is moving at the equator. Now, the closer you get to the poles, the slower it's moving, but still. So 625 miles per hour is a little fast. And it produces a little bit of momentum. Anybody who's taken a weight or something, put it on a string and swung it around, you can feel it pulls out. Well, the same thing has happened to the Earth. If you're looking at it from the top, here's the North Pole. You're looking at it from the top. As it spins, the weight of all the material, the earthen material, actually pushes out. And it's just like a ball of clay. If you were to take a perfectly round ball of clay and you spin it, it eventually elongates because the material tries to push out at the center. That's what's happened to the Earth.
It's always changing. The shape of the Earth is always gradually.
Oh yeah, definitely.
And theoretically, one drastic
It was so the perimeter is 84,
Perimeter is 84.
and then the length is the width times 5.
So 5 times the width. Right there, like that.
Yeah, and I'm just like, I totally,
So
And
P
it won't
equals,
give you the width either, so you.
yeah, I totally.
yep. So here's what you got. P equals 2L plus 2W. You know, oops, I'll wait for you. Let me know when you're ready.
Going back to that, not going back to that.
We know that P equals 84.
Yeah.
So we're going to replace P with 84. We know that L is equal to 5W, so we're going to put in 5W for L. And 2W is just 2W. Now we have everything in the same variable. Everything's all in terms of W.
Well, we have to add them twos to it. I can do that.
So now we have to do the 2 times 5W, which is 10W, plus 2W. So now 10W and 2W does equal 12W. Okay, so at this point, yes, to solve that, we would divide by 12. Gets rid of the 12. 84 divided by 12 is 7. So W equals 7. So now we have to finish the problem. That's W. The length is 5 times W, so 5 times 7 or 35. So you have to be careful with MyMathLab. MyMathLab likes to ask for the length first. So that's why I solve the problem. I get the whole answer. Then I look at MyMathLab and see what it's asking for and make sure I put in the right answer. Otherwise, it's really tempting to, you get the 7 for W, you want to plug it in and get the computer to tell you you're right away. But that's not what it's asking for first. It's asking for the length first. You got to finish it off. Any other questions? Okay, well, there's a magic button on your calculator I want to tell you about. Depending on which style calculator you have, we have the Texas Instruments TI-30 with the 2-line display. It's somewhere up in here. It's this, I think it's about the second button over, second button down, and it looks like this. It's called the ABC key. It's the fraction key.
is my favorite key.
If you want to enter something like 8/12, you type in A, hit the ABC key, and then type in 12. And hit equals, and what does it do? Reduces it automatically to 2/3. Or you might put in 62/8, like that. 62 ABC 8, and it becomes 7 3/4. Everybody get that to work? Not even trying? Okay. So it automatically takes any fraction and reduces it for you. It also automatically takes any improper fraction and converts it into a mixed number for you. That's 7 3/4, not 6. So I mean, it does all those that reducing for you. What if I wanted to put in a mixed number? Well, then I just have to use the ABC key twice. If I want to put in 7 3/4, I would type 7, hit the ABC key, then 3, hit the ABC key again, and then 4. If I want to convert that, and of course it'll show up on the screen something like this, right?
Yeah.
It's the 7 3/4. If I want to convert that back into an improper fraction, like the 62/8, you'll see right above the key here, there's it looks like this, ABC to EC, like that, or DC, or whatever. It's the same button, but it's right above, it's on that same key, but it's written above it. What that means is that's what's called a second function, or a shift function, depending on your calculator.
Yeah.
To make the calculator do that, you've got this already entered in there, the 7 3/4. You hit second, then press that ABC key again. What you're really telling the calculator to do is what's above the ABC key, not the ABC itself. Hit equal, and it should spit out 60, or not 62 4/8. It'll spit out 31/4. Turn in. Did you hit shift and then ABC? Okay, here, I'll come over. It's not, suppose we see one like this, 47/7. I showed you how to use the calculator for it. But let's go through a long way of doing it. If you were to divide that out on a calculator, 47 divided by 7 is going to give you something like 6.71428574143 approximately.
Okay. I know.
But now you need to, the decimal doesn't do any good. So I always do it out long division with the remainder. 7 goes into 47 6 times. 6 times 7 is 42. That leaves us with 5 left over, so it is 6 5/7. Now entering that can be kind of tricky. You do 6, and then you do the fraction template. 5, arrow down, 7, and yay. Yes. Now doing from 7 2/5 back into an improper fraction. Yes, we're taking, remember what that's telling us to do is take these 7 whole objects and break them into pieces. Each of them is going to have 5 pieces. So 7 times 5 is 35 pieces, plus the 2 is 37 pieces, so 37/5. Now if it's just a simple fraction, you can actually get away with just doing 37/5, and it'll automatically convert it. That's all the rest of these are, is just converting. Like 37/4. 37 times 4 is 148, plus 9 is 149. Or plus 1, I should say. 149. I said plus 9, but I added the 1. Okay, so this one, 5 times 34 is 170. This is number 34.
No, 181.
181? Yeah, there you go. 181. 170 plus the 11 is 181. You were working ahead. That's not fair.
I'm a slow writer. I had to.
She glanced at it, knew the answer, and decided to put it in.
Wouldn't that be awesome?
Just go with it.
Oh, yeah, I did.
Okay. So that's pretty much it for the homework. Any particular problems that's been giving us trouble that you want me to spend the last 5 minutes on? Homework 6, I believe, yes. Well, this is homework 6. Yeah, homework 6, I think it's quiz 5. No, quiz 5, isn't it? We'll check. It's got to be quiz 5. All right, you're right. It is quiz 4. It is quiz 4. I'm sorry.
Yes, I get an extra 5 points.
You should put some extra